Good afternoon, students. So in our last class we complete the exercise 3.3. As noted, I hope all of you complete this exercise. So next one is very important topic here, and which one is elementary operation, or also we can say it is a transformation of matrix. So very important topic here. So actually what is operation? So elementary operation or transformation. Transformation means how can we transform a row or a column. So mainly here, if you identify, there are mainly 6 operations we get, 3 for rows and 3 for columns. And now here the elements are we have to transform, so that's why it is known as elementary operation or transformation. So here mainly 3 operations are we have to do. So first one is here written, you see here, interchange of any 2 rows or columns. So that means in this case what you have to do, the meaning is what here, we can easily interchange any 2 row or any 2 columns. Suppose this one is the first row, second row, third row, which one is we defined by capital letter R1, R2, R3. R1 means the first row, R2 means the second row, R3 means the third row. Similarly, we can define C1, C2, C3, or it may be C4, C5 also. So column 1, column 2, column 3. In this way we can define. So interchange of any 2 rows or any 2 columns. So if you interchange, suppose R1 we have to interchange with R3. So which one interchange symbol is like in this way we have to write R1 interchange R3. So that means what is the meaning? The first row we have to write in the third place and the third row we have to write in the first place. So that's why here we write, you see, G, H, I, D, E, F, A, B, C. Is it clear? This one is simply interchange of any 2 rows or any 2 columns. Is it clear? So you can exchange column also. Is it clear? So next one is number 2. If you see here number 2 written, multiplication of any row or column by non-zero number. Non-zero number means any scalar quantity. So if you consider a row, any one row or column you can consider, if you multiply a non-zero number, suppose if we consider k, so here we write the result like in this way, R3 transform, not interchange, here transform, R3 into k. That means we have to multiply a scalar with this, so k into R3. So k into R3 means with row 3, the meaning is what here, row 3 we have to interchange, and here with row 3 we have to multiply it by k. So that means with each and every element we have to multiply with k. So other two are remain same, and R3 we have to transform, so that's why k7, k8, k9 in this way we can write. So one more important thing here, when we transform, if the order is 3 by 3, then maximum we interchange or we transform maximum 2 rows or 2 columns if the order is 3 by 3. If the order is 2 by 2, then we can interchange or transform only 1 row or column. Is it clear? Always one less. So next one is, now the third one is, you see here, addition of any row or column. So addition of any row or column means what? Suppose one matrix we consider, and now here this first row we have to transform. And how can we transform? We can add or subtract. You can subtract also, but here mainly we write addition. R1 we have to transform R1, and what we have to do? R1 plus R2 we have to do here. Suppose you can do this one, R1 plus R3 also according to your question situation. So now here R1 transform R1 plus R2, so that means what we have to do? We have to transform this first row. And how can we write? R1 plus R2. So 1 plus 4, 2 plus 5, 3 plus 6. Which one is written here? You see. Is it clear? And we transform only the first row. Other two are same. So that's why we write 4, 5, 6, 7, 8, 9. Is it clear? So in this way, we can transform the row or column. Is it clear? Okay. After elementary operation or transformation of a matrix, next another very important topic is here, and which one is known as invertible matrices. So invertible matrices, how can we write down the invertible? So simply, if anyone asks you what is the invertible of, suppose any question here given 2, number is given 2, what is the invertible of 2? Then what you have to say, 1 by 2 is the invertible. That means the inverse one. So similarly here, invertible matrices, how can we write? Or what is the theory actually? Is it clear? So for this, suppose we consider an example A. A matrix is we consider here 2, 3, 1, 2. Similarly, another matrix we have to consider B, 2, minus 3, minus 1, 2. Is it clear? These two matrices we have to consider by our own. So now what you have to do, we have to multiply these two. If you multiply these two, and after multiplying, you see here the result. After multiplying these two, the output, the result, whatever you get, this one is an identity matrix. 1, 0, 0, 1. This one is an identity matrix or not? Which one is we represent by I? Or if you multiply BA, because AB is not equal with BA, so if you multiply BA, again you get identity, then which one we represent by I? So if you get this result, the multiplication of two matrices is identity, then for the first matrix, the second one we can say the inverse. Like if you multiply 2 with 1 by 2, then the result is what? 1. So in this case, what we can say, for 2, 1 by 2 is what? The inverse one. Similarly, if you multiply these two matrices, and for the first one, if you get the second one, multiply, when you multiply, and if you get the identity, then for the first one you can say the second one is the inverse. Or in this case, BA, what we can say, for BA is the inverse. Is it clear? So now here B is the inverse of A, we write, and similarly A is the inverse of B, we can write. Is it clear? Inverse matrix or invertible matrices. When we multiply two matrices, and if the result is identity, then for one matrix the another one is what? The inverse one, or which one we can say invertible, or which one we represent by B equal to A inverse or A equal to B inverse. Is it clear? Okay, now after that, now you see the theorem number 3, which one is given in your book, page number 91, uniqueness of inverse. So uniqueness of inverse means what? For one matrix, a unique inverse we get. That means for a matrix we get one and only one inverse. Is it clear? This one is theorem given in your book, you can see from there. And another one theorem is here, and this result very important. Is it clear? This result is very important. So here AB, not this one is AB actually, this one is AB inverse. So you see here AB inverse, this result AB inverse equal to, we can write V inverse A inverse. This one is actually a result, and this proof is also given in your book, you can see from there. Is it clear? So uniqueness of inverse means for a matrix we get one and only one inverse, and AB inverse, in place of AB inverse we can write B inverse A inverse. Is it clear? Okay, after invertible matrices, now if a matrix given to you, so how can we find out the inverse of a matrix? Is it clear? How can we find out the inverse of a matrix? By elementary operation. That means the three operations are we get there, and with the help of these three operations, how can we find out the inverse? So mainly when a matrix given to you, then mainly we get two operations. Here written you see, one is row operation, another one is column operation. And one of the most important part is what here, when we start row operation, so we have to complete the question through row operation. Is it clear? If we start from column operation, with the help of column operation, if we start, then up to finishing we have to apply only the column operation, we can't apply their row operation. Is it clear? So that's why separately here written. So there is a method, or there is a technique to write how can we prove the result actually, or how can we find out the inverse. So for row operation we have to write this result. A equal to I A. A is the given matrix whatever given to you, and the result we have to write in this way: A equal to I A. I means the identity matrix. This identity matrix totally depending on your question. If the question order, if the given question order is 3 by 3, so here we have to write 3 by 3 identity matrix. If 2 by 2 given, then we have to write here 2 by 2 identity matrix. So now in column operation, what you have to write? We have to write A equal to A I. You see the difference? A equal to I for row operation, and for column operation, what you have to write? A equal to AI. So actually what we have to do, how can we apply the operation here? Let's see. For this, let's take an example. So we consider a matrix A. We consider matrix A equal to 1 to 2 minus 1. So now our task is what? We have to find out the inverse of this A matrix. That means we have to find out A inverse. How can we find out A inverse? Let's see here. So at first, what you have to write? We have to write A equal to IA. For row operation, we have to write A equal to IA. And then the A matrix whatever given here, we have to write here equals to, with respect to this, we have to write on the identity matrix, and in place of this A, we keep same this one. You see, we keep same this one A. The first A we have to write, then identity matrix write, we keep this A same. Similarly, in the column operation, you see here A equal to, we write down the given matrix, then we keep this A, and in place of I we have to write what? In place of I, what we have to write? We have to write identity matrix. If you see here, A, we write A matrix, then we keep A, then in place of I we have to write identity matrix. Is it clear? Okay, now why we write this one is identity matrix? Because you see here already in the not last class, in last part here, when we write invertible matrices, what we write? The multiplication of two matrices identity, so that means we write AB equal to I. So this result we have to write. You see, the multiplication of two matrices identity, that means what we can write from here? B equal to A inverse. So this technique we have to apply here. For that reason, what you have to do here, we have to convert this result. We have to convert this result to identity matrix. Is it clear? We have to convert this result to identity matrix with the help of elementary operation. Similarly, here we have to convert this result to identity matrix with the help of elementary operation. Now one more thing here, when we apply the elementary operation here, at the same time the same procedure or same step we have to apply here also. Is it clear? And if you are applying, if you get this one is identity, then this result we consider as a B. So BA equal to, if you get I, then A inverse equal to B you get. Similarly, if you get this one is I, then AB, it is of the form AB equals to I, that means B equal to A inverse we can write. Is it clear? So in this way actually we can apply the row operation and the column operation. Row operation means mainly what you have to write? A equal to I and A equal to AI. Later on you have to do some questions, then it is more clear, because elementary operation is not so easy. So next you see here this one. Actually this one is a technique how can we convert into an identity matrix. So first of all, this element is what? The first row first column element. So when we start the first row first column element, we have to convert to 1, and after converting this one to 1, the second element here, the third element, with respect to this one we have to convert this to 0, and then we move to here. You just see the chain here. How can we convert? In question you know more properly here. Just you see here, with respect to this one we have to convert this one to 0, 0, and then 1, and then 0, 1, 0, 0. Now how can we apply this one in the next question? You know this one. Is it clear? So the same thing we can apply for column operation also. From where we have to start and how can we write? You see 1, 0, 0, then 1, 0, 0, 0, 1. This one is actually steps. In 6 steps we get the identity matrix. If you follow these steps, very easily you get the answer. Is it clear? So now see carefully these two. Now one question we have to take from here. Okay, let's take an example. So here we directly write a 3 by 3 matrix. You see here the question is asking here, find the inverse of this matrix with the help of elementary operation. So now here at starting we write two operations are there, row operation and column operation. Here we take the row operation. So that's why we have to write A equal to IA. You see written. So in place of A we have to write this matrix, whatever the given matrix we have to write, and then identity matrix we have to write, and this A we keep same. Now the procedure is this one. With the help of this technique we have to apply. So our first task is what? We have to convert the first row first column element to 1. So we need the first row first column element is 1. So how can we take? You see here, if this matrix, if you see in the second place, because we are applying the row operation, so in the second place here it is 1 or not. So we can interchange these two. In elementary operation we can interchange two rows, so we have to interchange these two. So if you interchange these two, so in place of R1 we write R2, in place of R2 we write R1. So that's why here written R1 interchange R2. So 1 2 3, the second row we have to write in the first place, and the first row we have to write in the second place, and the third one is remain same. Is it clear? So the same thing we have to apply here also. So that's why we write here the second row is 0 1 0, so 0 1 0 we write, and the first one is 1 0 0 we write. Is it clear? Okay. Now after getting this one is the first row first column element is 1, what you have to do? The next element we have to convert to 0. So here you see the next element is 0, so no need to convert here. Then after that this element also we have to convert to 0 with respect this one, with respect to this one. So how can we convert? So now here you see the last element is what here? This one 3. This one is 3. So the meaning is like in this way you have to see, if we multiply a 3 with this one, then we get result is 3, and then if you subtract from this 3, then 3 minus 3 what you get? 0. So in this way we can convert. So that's why we say here with respect to 1. Is it clear? So now here what you have to do, we have to transform this third row, isn't it? So third row, so that's why we write R3. We have to transform R3, so that's why at starting we have to write R3. And one more thing you have to remember here, with this R3 we can't multiply any scalar. Those row or column which one we have to transform, we can't multiply anything with this. So that's why R3 we have to transform, so that's why R3 we keep same, minus this one is the first row. With first row if you multiply 3 then and subtract from the third row, then you get the result is 0. So that's why here we write R3 transform to R3 minus 3 R1. So if you multiply with this 3, then 3 minus 3 you get 0. Is it clear? So that's why you see here 3 minus 3 you get 0. So the same calculation if you do from for this, so R3 means 1. 1 minus how much we have to multiply with this result? 3. 3 to the 6. 1 minus 6 minus 5. Similarly here you see 1 is there, 1 minus 3 into 3, 9 minus 8. So the same thing we have done here, we get this result. After getting this one, now you see here the next step. This two we get 0, you see this two 0. After that we convert this one into 1. So now here already it is 1. So no need to transform here. So after 1 what you have to do? Next element this one we have to 0 with respect to this one. With respect to this one we have to convert this one to 0. So here it is you see minus 5 and here it is 1. So that means with R2 if you multiply it by 5 and add with R3 then you get the result is what? 0 or not? So which one we have to transform? We have to transform R3. So that's why R3 transform R3 plus 5 R2. 5 we have to multiply and add with this. Minus 5 plus 5 0. So that's why you have to write here 0 0 and then it is 2, because if you multiply with this one 5 5 to the 10 here, 10 minus 8 2 you get. Similarly here you get. So now after getting this one 0, now you see here after getting this one 0 we have to convert this one into 1. So here already 0 0, so easily we can convert this one into 1 with the help of any scalar we can multiply. So we transform R3 and we have to multiply with 1 by 2. So 1 by 2 into 2, the answer is 1. So that's why we write here 1. So in this way, the same procedure here you see, we multiply R2 transform to this one. In this way we have to calculate if these two operation you apply, then these two results are 0 and finally you get this one is 0. So in page number 94 this question is actually done. So from there also you can do this one, and lots of questions are there in your exercise, so you have to practice this one little bit more than the other questions. Is it clear? So in this way we can do, or in this way we can find out the inverse of a matrix with the help of elementary operation. Is it clear? Okay, thank you.